we're going to talk about 7-1, ratios and proportions. You've probably heard the word ratio before. The word ratio means to compare two different things, right? And so if I look at something, and let's say that in my classroom I have 3 girls and I have 4 boys, then if I'm trying to express a ratio, then the way I'll express that ratio is to say that there's a comparison between 3 girls and 4 boys. And that's usually how we write a ratio. Another way that you can write a ratio is to write it as a rational number or as a fraction. So I can also write it this way, the same ratio of 3 girls to 4 boys, where I've written it now as a rational number, and that is where the word comes from, right? The word rational comes from the word ratio, and so that is an expression of a comparison between two things. Okay, so when we use this, right, we can use it for things like batting averages. Batting averages are calculated by finding a ratio. How many balls have been hit out of 100, right? So if you have a batting average of 343, then you've hit 34.3, or you've hit 3.343 out of 1, right? Or 343 out of 1,000 when we think about those things. So when we look at it in terms of geometry, we're looking at terms of comparison. So for example, I can say, for example, let's look at a rectangle. All right, so let me draw a rectangle here. Let's draw a rectangle. Okay, and if I tell you that I have one side is twice as long as the other side, if I say that the long side here, okay, is twice as long as the short side here, then what I'm talking about is a ratio. It is a comparison. And so I can express it by saying that the length of the red side is 1. Okay? And if I tell you that the green side is twice as long, I can say that its comparison is 2. And so when we compare them, the ratio then of the long side to the short side is 2 to 1. And we can say this, right? You'll see it in geometry written as something like the length of the rectangle is twice or 2 times the width. And so we do see it that way when we're talking about geometry. The other way we deal with it is we deal with it in terms of proportions. Okay, a proportion is a comparison of 2 different ratios. And so typically when we look at a proportion, we see something like this, right? If I want a proportion, I'm comparing 2 ratios or more, but typically 2. So we're going to compare 2 ratios, okay? And they're equal ratios, and so we usually express them like this, okay? A over B is equal to C. Oh man. There we go, switch it back to black. C over D, okay? And so we know then that the comparison of A to B is equal to the comparison of C to D. There is something in proportions that we call cross products, okay? A cross product, let's pick something bright that I can use to make a product. A cross product is when I multiply across the equal sign, okay, and the 2 sides of that are equal, and that's what makes the proportions equal. I know that A times D is equal to, let's fix that, equal to B times C. And when these are equal, then I've created what's called an equal proportion. So how does that affect geometry? Let's look at some shapes. Let's suppose that I have 2 triangles, okay? Let's draw this kind. So I have one triangle here, and I have one triangle here. And let's say that I tell you that the proportion of the triangles is 3 to 1. Okay, let's suppose that the big triangle is 3 times, whoops, forgot to switch it back to a writing pen. All right, let's say that the triangle is 3 to 1. And let's suppose that that's true. You know, the figures aren't drawn as size, but let's suppose that that's true. And let's suppose that these triangles have a proportion, and I want you to find out different pieces. Okay, so let's say that I tell you that, let's name the triangles really quick. Let's name them A, B, C, and D, E, and F. And let's say that I tell you that the proportion of them is 3 to 1. Okay, so let's say that I tell you that AB is equal to 15, okay, and that BC is equal to 12, and that AC is equal to 6. This isn't a right triangle, so we don't have to follow all those weird right triangle rules. But if it's 3 to 1, I can solve a proportion by comparing these two polygons. Okay? And there is a rule in geometry, and we call them similar polygons, but we'll come back to that later. But let's say that these two polygons, we're looking at them, and I want you to find the lengths of the other sides of the triangle, right? So I'm going to compare them. I'm going to compare the length of this side here to the length of this side here, because that's the sides that match, right? Those are the sides that match. And so from that, I know that AB, when it's compared to DE, will create me some kind of proportion, right? And so because I know that the proportion is 3 to 1, okay, if AB is 15, okay, and the ratio is 3 to 1, I probably shouldn't have written that way. Let's do this. Let me go back, let me fix that really quick. Rather than calling it equals, we'll do a ratio marker there. I think my calibration's gotten a little off. All right, so if AB equals 15 and the ratio is 3 to 1, DE is then 5, right? Because it is 1/3 of that. I really think that this has gotten off a little bit. Okay, so hopefully you can see how the proportions and calculating proportions makes it easier to calculate these things for geometry. We will do similar polygons for a different lesson on another day.